What's up everyone, Patrick here, welcome back, and in this next video we are told that the formula F equals P times 1 plus R in brackets to the power of n represents the future value, which is represented by this F variable, of an amount P that is invested at an interest rate R for an n number of years. This is basically the time value formula for a cash flow. Sometimes you'll see it represented as the future value equals the present value times 1 plus R to the power of n. Or sometimes you may even see other letters be used as variables. But we're dealing with time value here. And given that formula, we have these three different scenarios to go through. So number one, at what interest rate will $1,000 invested for 4 years grow to $1,288.88? Number two, how many years would it take for $5,000 to grow to $6,873.97 at an interest rate of 3.6%? And then number three, the toughest scenario of all of them, in my opinion, you invest $1,000 now into an account, and 3 years later you invest another $1,000. The value of the account in 6 years is $2,411.36. At what annual interest rate did your account grow? So in number three, we're actually going to have to create an equation where we're going to use the formula twice. But we'll get there. So I'm going to erase 2 and 3 for now. I'll bring them back as the video progresses. So let's start with number one. At what interest rate will $1,000 invested for 4 years grow to this amount over here? So what we would do using this formula is just plug in everything that we are given in this scenario. So we know we're investing $1,000, so that's the amount invested today. And we're going to be solving for the interest rate R, and it's invested for 4 years, and it's going to grow to this final amount, this future value F, which in this case is $1,288.88. Right, so now we have to solve for this R. So basically all these scenarios is just algebra practice for solving different variables in that formula. So in this case, we're solving for R. First thing we would do is this 1,000, notice it's attached to here, so we can divide everything by 1,000 because you're multiplying here, so to get rid of it, you got to divide it. So notice that these would cancel out, and then you'd be left with 1 plus R to the power of 4, and then this over here would just be 1.28888, like that. Right, and how do we solve for this R? How do we isolate for it? Well, notice we have this exponent here, 4. And so to get rid of that exponent, what we can do is we could take both sides to the power of the reciprocal of that exponent, which would be 1 over 4, like that. Right, this is like 4 over 1. So taking it to the power of 1 over 4, notice when you multiply these, you'd end up with just 1 in the exponent. So the 1 plus R would be by itself, and then this here you have to the power of 1 over 4. What you do to one side, you got to do to the other. Another way this could be written is the 4th root of this amount, right? And then the 4th root of this. Personally, I like to use rational exponents. All right, so from here, what would happen is, again, this times this is just 1, right? If you multiply something by its reciprocal, it's always going to be 1, so we'd end up with 1 plus R to the power of 1, which we don't have to write. And then this over here, let's just leave this as is for now on this left side. And when you actually do this calculation, what you would end up with is 1.0655 approximately. If you round to 4 decimal places, if you do this in your calculator, when you're taking it to the power of 1 over 4, make sure you put that in brackets. And then the right side stays the same. Bring the 1 over, and you'd have 1.0655 minus 1, which would give you 0.0655. And so that's the interest rate. Now this interest rate in this formula, it's always going to be a decimal, as you see. So if you want to convert it to a percentage, you would just multiply it by 100. So you'd get 6.55%. Right? That's the annual interest rate. And you could check your answer. You could take this, plug it in here. Remember, whenever you're plugging the interest rate in, if they give you a percentage, you got to divide it by 100 to convert it to a decimal. Or if you're solving for the interest rate, you're going to get a decimal. And then to convert it to a percentage, you got to multiply it by 100. So you could test this. You could take this, put it in here. N would be 4, P would be 1,000, and see if you get that amount. Moving on to the second scenario. So how many years would it take 5,000 to grow to $6,873.97 at an interest rate of 3.6%? So again, we're going to use that same formula. In this case, though, we're going to be solving for a different variable. We're going to be solving for the n. How many years would it take to grow? So notice that we're given the initial amount, 5,000. We are given the interest rate of 3.6%. Remember, when we plug it in for R, it has to be a decimal that we plug in. And then the n we're solving for. And then the future value is the $6,873.97. So how do we solve for n in this case? The process is actually going to be a lot different than solving for R. So what we can do here is we divide both sides by 5,000. Right, so these cancel out, so we're left with these we can combine into one expression. And then when you do this, this amount divided by 5,000 would give you 1.3748 if you round it to 4 decimal places. I recommend not rounding to too little decimal places at this point in order to get a more exact value, more exact final answer. And so you'd end up with this. Question is, how do we solve for this n here? Well, what we would actually have to do is we would have to log both sides or ln both sides. Right? So what we would do is we would ln this side and then ln this side. So if you remember your logarithmic rules, the reason why we want to do that is because whenever we have the logarithm of, let's say, a to the power of b, we can bring that exponent down. That's the same as b to the power, or b times ln a. Right? This is the same as this. And so we're lnning this, so what we can do now is we can bring the n down. Right? Ln is the same as log. And so what would happen is we'd end up with ln of 1.3748 equals, we bring the n down, times ln of 1.036, like that. And then we can divide both sides by ln of 1.036. Divide this by ln of 1.036. Right, when you do this, be careful with your brackets. These cancel out, and when you do this calculation, you'd get an approximate value of 9. Right, so that would be the final answer. So it would take 9 years for this amount to grow to this amount at 3.6%. And again, you could check your answer. You can take this right side, take 5,000, multiplied by 1.036 to the power of 9, and you should get something very close to that. That's how you could check your answer. And finally, moving on to the third scenario. This is going to be the toughest one. There's going to be a lot of algebra in this one, as a heads up. So you invest 1,000 now into an account, and then another 1,000 3 years later. The value of the account in 6 years is this amount, $2,411.36. At what annual interest rate did your account grow? So before setting up the equation here, I actually want to show you visually first what's happening. is, let's say we're in time 0, which is right now. And so what's happening is we're investing 1,000 right now. And then 3 years later, we're investing another 1,000 into the same account. And then what happens is in 6 years, the account is worth this much. And so what basically happened was this 1,000 accumulated interest for 3 years, and then this 1,000 accumulated interest for 6 years. And then both of them summed together, the future values of both of them summed together, ended up giving us this over here. And so the way we can create an equation here is we could look at both of these separately. So let's forget about this 1,000. Let's even forget about this number. What would be the future value of this 1,000 invested today in 6 years? Well, using that formula, we know the future value of that would be 1,000, 1 plus r to the power of 6, right? It's gaining interest for 6 years. And this future value here, this is in time 6, so let's symbolize this as f subscript 6, like that, right? The future value in the 6th year. Now let's forget about this 1,000 and look at this 1,000. Here we can set up an equation with this 1,000, the future value of this 1,000 in year 6, but we're investing that 1,000 in year 3, so notice that this 1,000, it accumulates interest for 3 years, and so the future value of this 1,000 in the 6th year would be 1,000, 1 plus r to the power of 3, right? Because it only accumulated interest for 3 years. So this represents the future value of this 1,000, and then this represents the future value of this 1,000, and we know that both of them summed together have to give us the value of the account in the 6th year, which is this amount. And so what we can do to set up the equation is we can take both of these expressions. So we'll take the 1,000, the first 1,000 invested today, the future value of that, plus the future value of the 1,000 invested in the 3rd year for 3 years. And we know that the sum of that has to equal the future value of that total account, which is $2,411.36. And notice now we have an equation, and we just have to solve for that r value. The question is, how are we going to do that, right? If we take all of this and expand it, so 1 plus r to the power of 6, notice how many brackets we're going to have to FOIL out, and then this, we're going to have to FOIL out all those brackets, bring this over. It's going to take a lot of work. We can do this with trial and error. That is another way, but there's actually an algebraic way to do it. And it's from how the 3 and the 6 relate. Notice that the 6 is double the 3. This exponent is double this one. And so what we can do is we can actually take this here, this expression, and we can rewrite it as 1 plus r to the power of 3 to the power of 2. And I'll show you why I'm doing that in a sec. Let's rewrite the rest as is. And the reason why is because now, notice that we have this expression 1 plus r to the power of 3 showing up twice in this equation. And whenever you see something like that, it's always usually a good idea to introduce another variable. So we can let m equal 1 plus r to the power of 3, that expression that is coming up twice. And notice what would happen. This would be m, right? So we would end up with m squared. this would be m, so we'd have 1000m, and then we'd have this constant on the right side, and notice now we have a quadratic equation that we can always solve with the quadratic formula. And so that's the trick in this question, is bringing in another variable, realizing that's just a quadratic equation. We could solve for m with the quadratic formula and then bring this back and then solve for r. Now, another thing I want to mention is that in this particular question, this is 3 and 6, but if you get a similar question like this is a popular question. Basically, these can be anything. It's just usually this is going to be double that. So it could have been 2 and 4 over here, or it could have been 4 and 8, or 5 and 10, right? Same sort of process would apply. You would just split this up to b to the power of 2, and then this and this would be the same, right? So in this case, it was 3 years and 6 years, but you could also have 2 years and 4 years, or 5 years and 10 years. Same exact process would apply, just with different numbers. All right, so from here, what we can do, how do we solve a quadratic equation? Well, we bring everything to one side, so let's rewrite this. That's going to equal 0, and we could just plug this into the quadratic formula, right? Because the a value is 1000, the b value is 1000, and then the c value is negative 2411 and 36. And so the quadratic formula, the m in this case, is negative b plus or minus square root of the discriminant all over 2a. And so plugging this in, plugging everything in, the b value is 1000, so we'd have negative 1000 plus or minus 1000 squared minus 4 times the a value of 1000 times the c value of negative $2,411.36, right? All over 2 times the a value, which is 1000, right? So we would just solve that right there. And then working with that quadratic formula, you'd end up going through these steps here. So you would take this amount under the square root, the discriminant, the value of the discriminant would be 10,645,440. Square rooting that, you'd get this amount over here. Don't round at this point because there's a lot of algebra going on here. And remember, we're just solving for m still. We still have to solve for r. So don't round too much here. So the square root of this would be this. And then the two values, you take negative 1000, add this, then divide it by 2000. And you would get this amount for m. And then negative 1000 minus that amount, it would be like negative 4000 and something, divided by 2000, and you would get this amount. And so notice for the m, we got two solutions. We got a positive solution and then a negative solution. But notice in this question, we're solving for an interest rate. And though interest rates can be negative, it's very unusual. And so we can assume that when we're solving for that r, it's going to be a positive value. And so we would actually ignore this over here. Because if we took this, negative 2.13 for m, to solve for this r, we got to take both sides to the power 1 over 3, or the third root of both sides. This here, the third root of a negative number would give us another negative number. And then we'd have 1 plus r, and then when we bring the 1 over, we'd have a negative value on this side, right? But we want r to be positive. So this m we would ignore, and we would actually just plug in this m for that. We got to bring back this substitution that we made and then bring back the r, because that's what we're solving for eventually. We're not solving for this m. That was just a preliminary step in order to make this equation look smoother, right? So we're going to use this m value, and then we got 1 plus r to the power of 3. How do we isolate for that r? Well, we take both sides to the power of 1 over 3, or the third root of both sides. And when you do this in your calculator, you'd end up getting approximately 1.042. And then this times that would be just 1. 1 plus r to the power of 1 is just 1 plus r. Bring the 1 over. R would be 0.042. Or, if you remember, this is always going to be a decimal. If you want to convert it to percentages, multiply it by 100. 4.2% is the answer. Right? So that's the answer to number 3. That's the interest rate at which that account grew, that annual interest rate. And again, you could take this and you could check your answer. So with that formula we had, you could take the 4.2%, the initial 1,000, 1 plus 0.042 would be 1.042 to the power 6. And then that second 1,000 that we invested 3 years later, that's growing for 3 years. And you could test it and see if you get something very close to that future value amount. And if you do this here, you would see that you would get something very close to that. Right? So the answer for number 3 is 4.2%.